Okay, yeah, hi everyone. So this is Rosyth School Preliminary Examination Paper 2. So it's a continuation of last week's paper. So we'll be skipping the first two questions for this paper and jump straight to question number 3. I think it's a tricky question over here. So for question number 3, okay, so Katie wanted to cut out isosceles triangles with a base of 2 cm and a height of 2 cm as shown below from a rectangular piece of paper. So the paper measures 16 cm by 25 cm. What is the most number of such triangles that she can cut out? Okay. Okay, so if you look at this triangle, it's an isosceles triangle, and it's quite difficult for you to actually try to visualize this. So what I did was, okay, maybe I share with you how to solve this question. So I will share, I will do this in word form. So it's neater for you to see. Okay, so if I look at this diagram, what I did was I actually stacked my triangles in this manner. So remember the length of the piece of paper is 25 cm. Okay, so this is 25 cm. And then the breadth is 16 cm. So it looks something like this. Okay, so this is 16 cm. So if I were to line up my triangles, I try to make that as compact as possible. So if I look at the base of the triangles, I take 25. If I were to divide by 2, okay, I get my 12 triangles and remainder of 1. So do you see over here, there's 12 triangles? Maybe I use another colored pen. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And of course, there's a remainder of 1 cm over here, which cannot fit any more triangles. This is the remainder. Okay, then if I do the same for the opposite, so I will stick together, there's also equally another 12 triangles at the top. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. It's possible to squeeze in one more triangle at the end because of this extra 1 cm at the back. Okay, because of this remainder. So I know that for one layer for the length, I can have 12 triangles multiplied by 2, which gives us 24 triangles for one row. See, you guys see that? So one row, there's 24 triangles. Okay, and then if I look at the length, I will stack up in this manner. Okay, so I will align my triangles since the height and the base is 2 cm. So all 2 cm, right? So if I take my 16 divide by 2, I will get 8. I'll get 8 stacks. Correct? So there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 triangles, or rather there's 8 stacks on the breadth. So how do you find the total triangles that you can fit in? I can multiply 24 by 8. Okay, so 24 times 8, you get your answer, 192 triangles. So that's the answer for question number 3. Okay, so you can refer to this for question 3 on the diagram of how it looks like. Okay, so let's go back to the question. Okay, so that's the answer for 3. You have 192 triangles, and I showed you the solution earlier on. Okay. Now, question number 4 will skip as well because question 4 is actually all right. Okay, let's move on to question number 5. Okay, 5. Now, Sam only had the following notes and coins in his saving box. The notes are $2, $5, and $10. The coins are 10 cents, 20 cents, and 50 cents. On Saturday, he took out the least amount with a note and a coin. What was the total amount of money taken out from the saving box on Saturday and Sunday? Okay, I think this question is quite simple enough. So if I were to look at the least amount with a note and a coin, I will look for the lowest valued note. Okay, so for my lowest value is $2, and the lowest value for the coin is 10 cents. So I take $2, I plus 10 cents. Okay, I get $2, 10 cents. This is the value for my Saturday. And then for Sunday, I have $10 plus my 50 cents. So I get $10, 50 cents for my Sunday. So this is quite simple. Just look for the highest valued note and your coin. So how do you find the total money taken out from the saving box? I will add them up together. So 10.50 plus my $2.10. Okay, I get my number $12.60. Okay, so that's the answer for question number 5. $12.60. Okay. Let's move on to the next question. So question number 6, I will also skip. So let's move on to question 7. Okay, so machine A is able to print 50 stars in a minute. For every 1,000 stars that machine A prints, machine B is able to print 500 more stars than machine A. So how many more stars will machine B print in 2 hours than machine A? Okay, so if I look at machine A, every 1 minute I can print 50 stars. So 50 stars, okay, per minute. And for every 1,000 stars, machine B can print 500 more stars. Okay, so let's try to find the duration to get these 1,000 stars for machine A. So if I want to find for 1,000 stars, okay, I will take my 1,000 divide by my 50 stars. So 1,000 divided by 50, I'll get my 20 minutes. Okay, so 20 minutes means that I need 20 minutes to acquire 1,000 stars for machine A. Okay, so you want to find in 2 hours, convert your 2 hours to your minutes. So 2 hours equals to your 120 minutes, since every 1 hour is 60. So I want to find my groups. Every one group is 20 minutes. So 120, you divide by 20, I'll get 6 groups. Correct? You think of these as your groups. So you got 6 of this. Every one group, every 1,000 stars, I can print 500 more. So in 6 groups, I will print 6 times 500 more stars. So I'll get 3,000 extras. Okay, so your answer for question 7 is 3,000 stars. Okay, clear on this question 7. Okay, let's move on to question number 8. So there were 3 types of flowers in a garden. There were 352 stalks of orchids. The ratio of the number of stalks of tulips to the number of stalks of lilies is 5:3. The total number of stalks of tulips and lilies was 56% of all the flowers. So how many more stalks of orchids were there than tulips? Okay, now let's record your ratio first because you're given your ratio. So your tulips to your lilies is given as 5:3. Okay, and I also have the ratio for the total number of stalks of tulips and lilies. So tulips plus my lilies will be 56%. Okay, so this is 56, means that my total here is 100%. And I can also find my orchids. Correct? Because if I have my total is 100%, I minus off my 56. So 100, I minus my 56, I'll get 44% for my orchids. Okay? So once I record my information, I will try to look for my common base. Whenever you record your ratio, you shouldn't be solving straight the question. Instead, you should be looking for your common base. Okay, so what's the common base over here? The left-hand side, there's my tulips and lilies. The right-hand side, there's tulips, lilies, and orchids. Okay, so clearly my T plus L must be the common base. So when I proceed to find my T plus L, so 5 plus 3 means I have 8 units for my tulips and lilies. Okay, once you establish the common base, I will look for my common multiple. So when we say common base, we are not referring to the number, we are referring to the headers, the categories. So if I look at the numbers 8 and 56, my common base will be 56. So I will multiply this number by 7. Okay, same for the other numbers. You get 35 is to 21 is to your 56. That's the common base. Okay, so now I can solve the question. So that I look at the usable value here. So there were 352 stalks of orchids. I have the number for orchids. And if I look at the ratio here, orchids, there's 44 units. So 44 units equals to 352. I find for 1 unit. So I take 352 divide by 44. I will get my 8. Okay, I get 8 flowers for every 1 unit. Then your question wants you to find how many more stalks of orchids than tulips. So orchids, there's 44. Tulips, there's 35. Okay, so 44 units minus my 35 units. I'm looking at 9 units. So I find for 9 units, 9 times 8. So that gives me 72. Okay, so it's 72 more orchids than tulips. Okay, let's move on to the next question. So question number 9. The figure shows 2 stacks of identical cups. There are 5 cups in the shortest stack and 12 cups in the tallest stack. So the height of the shortest stack is 20 cm and the height of the tallest stack is 41 cm. So Shreya wants to pack the cards as shown into a box 0.6 meters long. What is the most number of cards she can pack into the box? Okay, so I'm given these 2 stacks of cards. Now what you can do first is you try to make use of these 2 measurements. Okay, so do you notice that for the first stack, I see 1 big cup plus extra 4 smaller tabs. Okay, you can call this is like 4 smaller sizes. Whereas for the 41 cm is 1 big cup plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so let's say you make this as L and you make this as S. Okay, so imagine all of these are S. So if I were to compare this, my 1L plus my 4S is 20 cm. My 1L plus my 11S is 41 cm. So do you see that you can subtract these two equations to find for my S? Okay, so 11 minus 4 means I will have 4 of the smaller thingies, 4 of the smaller S. Okay, so sorry, 11 minus 4 is 7. So I have 7 of these smaller S. Same for 41 minus 20. I subtract this, I'll get for my 7S. Okay, so maybe I put 11S minus 4S for clarity. 11S minus 4S, I get my 7S. So 7S equals to 41 minus 20, which gives me 21 cm. So I can find for 1S. Okay, so 21 divided by 7, I get my 3 cm. So each of this S is 3 cm. So if I want to find the length of this L, okay, I can use either equations. If I use the first one, I will take 4 times 3 to get 12. And then I subtract my 12 from my 20. Okay, so this part is my 12 cm. So if I want to find the L, I will take 20 minus my 12. I will get my 8. So my L here, this size here is actually 8 cm. Okay? So once I get my 8 cm, I can now try to find the number of cards I can pack. So this part here is 8 cm. The remaining will be my S, the smaller ones. Okay, so what do I do now? Change this 0.6 meters to your cm first. So 0.6 m. If I change this to cm means I must multiply this by 100. So I get 60 cm. Then I need to subtract off the first 8 cm for this L shape. Okay, for this L cup. So 60 minus my 8 means that the remaining 52 cm will be for the smaller ones for all the S. Okay, so if every one cup, for every one S, if it's 3 cm, I want to find the total number of S, I will divide by 3. So 52 divided by 3. Okay, so I get my 17 and remainder of 1 cm. So please do not write decimals over here and then round off. Try to record down, not try, you have to record down your quotient and your remainder. So 17 here means you can have 17S plus extra 1 cm. So this 1 cm is not enough to fit in one more cup. Okay, so how many cups can I pack all together? So I have 17. Then I must remember to plus back my 1, the first cup, which is the L1. So all together, you can have 18 cups. Okay. Okay, let's move on to question number 10. So question 10 is a Greek question. So I will try to draw as close as possible to the picture here. Okay, it's a little bit tough to draw out freehand on the computer. So a trapezium DEFG is drawn in the grid shown below. By joining the dots in the grid with straight lines, now part A, draw a parallelogram that has twice the perimeter of the trapezium DEFG using the line EF as one side label it EFKL. Okay, so you want to look at the perimeter of the trapezium first. For me, what I would do first is I will look at the straight sides versus the diagonal sides. Okay, so for straight sides, if I count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So straight sides. Okay, I have 10 units. For the diagonal sides, diagonal means is the one that cuts or drawn across. I have 2. Okay, so EF is called the diagonal side. So diagonal sides, I will use another form of quantity. I will not use 2U, I will put 2P instead. Okay, so diagonal sides will be 2P. Okay, so when the question says my parallelogram has twice, means it will be twice of 2P and twice of 10 units. So parallelogram, I know that the shape, okay, I have a general idea of the shape. It must have 2 parallel sides, which means I know I must draw this EF on the other side of my grid. I must draw somewhere diagonally across like that to fulfill twice of my 2P. Okay, for the straight sides, if I have 10 units over here, twice of this means I must have 20 units. So since your parallelogram, the length is the same, right? Is the same length. I will take 20U divided by 2. So means I must draw 10 straight sides at the top and 10 straight sides at the bottom. Okay, so let's draw our lines. So I will use another color if I use red. So let's mark out the 10 parts, the 10 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same for the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have my 20 units. Then once I get my shape, I will just draw the 2 diagonal lines at the side to form my parallelogram. So this is my EFKL. Okay, EFKL. Now for part B, draw a square from the point F that has the same area as the trapezium DEFG, label it FM and P, and both parallelogram EFKL, and the square should not overlap the trapezium and each other. Okay, so for the second one, we are looking at the area. So I can count the squares that make up this trapezium. Okay, so 1, 2, 3, 4, 5, 6, 7. And then these two combined will be 1 more square. So in other words, my trapezium, okay, is equivalent to 8 units square. So I assign each of the square to be 1 unit. So in other words, my trapezium is like 8 units square. And I know if I want to make a square, your square is made up of 2 triangles. Correct? Your one square will have 2 triangles. So I will try to find the area of one square by taking, area of one triangle. Let me erase my triangle. It looks very funny. Okay, by taking my 8 unit square, divide by 2. So I know that one triangle will be 4 unit square. Okay, 4 unit square. And if I revisit my formula for triangle, it will be half times my base times my height. So this must give me a 4. Okay. So I know that my base can be a 4, my height can be a 2. So I will let this 4 be the base. I will let this 2 to be my height. Okay, so I will try to draw 2 units below from here. This will be the height. Okay, maybe I use my highlighter. Okay, so 2 units from here, this will be my height. And then 4 units will be my base. So I'm trying to sketch out my square. So base of 4 units. And then height of 2 units. Then I draw my first half of my square. Okay, so I know if this is half of my square, I can draw the other half. So this is my square that I can label. So it should be my F, M, and P. Okay? Okay, let's move on to the next one. So question 11. Okay, it's on your ratio again. Now, an equal number of children attended Camp A and Camp B. The ratio of the number of girls to the number of boys in Camp A was 5:9. The ratio of the number of girls to the number of boys in Camp B was 4:1. Altogether, there were 132 more girls than boys. How many children were there in both camps? Okay, so we'll draw out first for Camp A. My ratio for girls to boys will be 5:9. For Camp B, the ratio for my girls to boys will be 4:1. So this is given in the question. Okay, then we'll look for my common base. Now it seems like there's no common base between these two, right? Because they are both of different things, of different groups. But do you notice over here there's a hint? You have the same number that attended the camp A and B. Equal number, which means that my total for camp A and the total for camp B, it has to be the same. So now I know my common base will be my total. So I find the total for camp A, I get 14. Camp B will be 5. Then since total is the common base, I will look for my lowest common multiple. Okay, so in this case, it will be 70 for each. So I will multiply my right-hand side, sorry, my left-hand side by 5. My right-hand side, I will multiply by 14. So I get my ratio for camp A, 25:45:70. My camp B will be 56:14:70. Okay? Once I get this information, I will solve the question. So altogether, there were 132 more girls than boys. So let's find the girls in total. Okay, so for girls, 25 units plus my 56 units. So girls will be 81 U. Okay, for boys, I will take my 45 units plus my 14 units. So this will be 59 U. I can subtract off. So 81 units minus my 59 units. I'll get my 22 units. So these 22 units equals to my 132. I solve for 1 unit. Okay, so 132 divided by 22, I'll get 6. So how do you find the children in both camps? So altogether, there's 70 times 2. So there's 140 units. Correct, 70 units times 2. So let's find for 140U. I take 140 times by 6. So it will be 840 children. Okay, let's move to the next question. So we'll skip question 12. So you may refer to the solution uploaded, the PDF version. Okay, for question 13, I will go through this now. So Claire had a roll of wire that was used to make stars. She used 3.75 meters of the wire to make 12 small stars and 15 big stars. There was some remaining wire left. She could not make a big star with the remaining wire as she would be short of 4 cm wire. She would be short of 4 cm of wire. So she made a small star with the remaining wire instead and had 3 cm of wire left. So what was the difference in the length of wire used to make a big star and a small star? Okay, this question, if I were to scan through the question, it reminds me and should remind you of your shortage and surplus. Correct? The one whereby you have to draw your model. You start with the original length of wire, and then you have to either add on or cut off from the length of the wire from the model. Okay, so we'll draw my model first. So let this wire, the one I draw over here, to be the 3.75 meters. Now what can I get from the 3.75 meters? So I label this. I can get my 12S, 12 small, and my 15 big. Okay, same for there's 2 scenarios over here. So we focus on the first scenario. So I use 3.75 meters to make 12S and 15B. Then there was some remaining wire left. Okay, so there's some wire here which you never used up. But if I make a big star, I am short of 4 cm of wire. Okay, so big star means that this amount here is not enough. I need to add on my 4 cm. Okay, maybe I put 4 cm inside. Okay, so 4 cm. Then this will be my 1 big star. Okay, now if I make a small star with the remaining wire, so same idea, the first 3.75 meters is for my 12S and 15B. So 12 small, 15 big. So this again is my remaining wire, right? But what happens is, if I make a small star, I got extra of 3 cm left. So this is my 3 cm, and this is my 1 small star. Okay, maybe I put like that. I think it's quite clear, right? This is my 1 small star. I got 3 cm of my wire left. So if you want to find the difference in the length of the wire for big and small, you compare your model over here. Focus on the difference, which is your 3 plus 4. Okay, so part A, what's the difference in the length of wire to make the big and the small star? So 4 cm plus 3 cm. So my difference is 7 cm. So that's the answer for part A. Now part B, what was the length of the roll of wire that Claire had at first? Okay, so based on this diagram, I know that my first equation is my 1B my one big star is equals to my one small star plus 7 cm. And I also know that my 12 small plus my 15 big will give me 375 cm. So I change this to my cm. 3.75 meters is 375 cm. So I need to do something. I need to change this, my 15b, in terms of my small, my 1s plus 7. Okay, so you convert this. So if I have 15 big, I must multiply this equation by 15. So 15 big will be equal to 15s, and then my 7 times my 15, I get my 105. So I can now change my equation. So 12 small plus, now replace your 15b with your 15s plus your 105. Okay, so I'm going to replace this. Equals to my 375 cm. So I just highlight this one in pink. Okay, you're replacing your 15b with your 15s plus your 105. So now I can simplify. So 12 small plus a 15 small means I have 27 small. So this 27 small is your 375 minus your 105. So this gives me my 270. That's for 27 small. How do you find for one small? Okay, I will divide by 27. So 270 divide by 27, I will get my 10. So one small star is 10 cm of wire. The one big star will be 10 plus 7. So one big star is 17 cm. Then now I can find my 12s plus my 15b. Okay, or I can find straight away 12 plus, sorry. Okay, so this is 3.75. So 375 plus my 1s plus 10 plus 3. So 375 plus this 1s, which is 10 cm, and then plus my 3 cm. So altogether, I get 388. Okay, so for the second one, you don't have to find the big actually. If I'm using the second model, if I'm using the first model, or if you have time to check, okay, then you will take 375 plus your one big, which is 17, but then you minus your 4. You should also get 388 cm. So this 1b here is only used for checking to see whether you're on the right track or whether your answer is correct. Okay? Okay, let's move on to question 14. I will skip. Okay, let's move on to 14. So the figure shown below is made up of identical semicircles of different sizes, 2 small, 4 medium, and 4 large. The length of the figure is 30 meters. Each of the small semicircle has a diameter of 5 meters. Okay, so part A, find the diameter of your one large semicircle. Okay, so what you can do first is you try to assign, or rather you try to draw out this small semicircle inside the big semicircle. Okay, so if I were to draw these out, you can just draw dotted lines. Okay, something like this. So draw in your dotted lines first. Okay, I will try to assign this one small part to be 1 unit. Okay, so this is my 1 unit. Then you try to count the units, the 1 units. So you assign the diameter of the smallest semicircle to be D. Okay, and then the small part here to be the 1 unit. So I will just put in all the D's. So D, 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 and D. So these are all my D's, and then these are all my units. Can you see? Okay. So do you see that because your 1D is equals to 5 meters, if I look at the entire stretch, there's actually 4Ds. Okay, there's 4D, which means I will take 4 times my 5 meters. This gives me my 20 meters. Okay, so my units, okay, so I put 20 down first. This is for part A. So 20 meters, I want to plus my U. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10U, this gives me my 30 my 30 meters. So I want to find for 10 units. I take my 30 minus my 20. So 10 units is 10 meters. Then you can find for 1 unit. So 10 divided by 10, I'll get my 1m. So this is 10 meters divided by 10. Okay, but you want to find the diameter of the large semicircle. So remember, this was your 5 meters. I must remember to add 4 of my units. Okay, so 5m plus my 4m means my diameter is 9 meters. So that's the answer for part A. Here we'll put down over here. This is 9 meters. Okay. Now part B, find the total area of all the shaded portions. So take pi equals to 3.14, express your answer to 2 decimal places. Now if I want to find this area, this shape, this rainbow shape, right? I will make use of my larger semicircle minus of my medium semicircle. Okay, so maybe I record my workings below because there's no space over here. Okay, so for part B, my largest semicircle has a diameter of 9 meters. Okay, my medium semicircle, if I look at the medium one, my diameter is 5 plus 1 and 1. So medium semicircle, the diameter is 7 meters. Okay, so you have to bear this in mind. So let's try to find the area of my 1 large semicircle. Okay, but if you recall over here, if you look at these rainbow parts, this shape, right? You realize you need 4 of this. Correct? And I know that every 2 semicircles equals to 1 full circle. So since my 2 semi, okay, so 2 semicircles is equals to 1 full circle, I can actually skip some steps. I can straight away find for 2 full circles because I'm looking at 4 semicircles here. Okay, so 4 semicircles is equal to your 2 full circles. Okay, so find the area for 2 big semicircles. So I take my 3.14 pi times my radius. So radius of the big semicircle will be 9/2. times my 9 over 2. So pi times radius. I will multiply by 2 straight away because I'm looking at 2 full circles. Now I will minus off my area of the 2 semicircles, the 2 medium semicircles. So I will take 3.14 again. Now for the medium semicircle, if you recall back earlier on, it's 7 over 2. The radius is 7 over 2 because diameter is 7, radius is half, so I must divide by 2. And then I multiply by 2 again because I have 4 semicircles. Okay, so if I subtract this, I get my 121.17 minus of my 76.93. Okay, so let's key in this in our calculator. Okay, I get 44.24. So this 44.24 is only for the rainbows. Okay, the one that's shaped like a rainbow. But when you ask for the shaded portions, I must include my 2 small semicircles. Okay, so there's one over here and there's one over here. So I will take my 3.14 times by 5 over 2 times by 5 over 2. Okay, and do I have to divide by 2 or times half? Don't need, because 2 semicircles give you a 1 full circle. So this one should give me 19.625. So once I get these two values, I will add them up. So 44.24 plus my 19.625, I'll get my answer 69.865. This is the area, but your question asks you to express to 2 decimal places. So if I round this off to 2 decimal places, I get 69.87. Okay, that's the answer for part B. 69.87 meters square. Okay, let's move on. I will skip question 15. So you can refer to the PDF answer key for question 15. Okay, let's move on to question 16. Okay, so Serene had some oranges in her shop. She sold 1/6 of them in the afternoon and 280 of the oranges in the evening. She was left with 3/5 of the oranges and she packed these remaining oranges into boxes. Okay, let's record the data for the first part. So for afternoon, okay, my ratio is, so if I have 6 units at first, I sold 1 unit, I'm left with 5. Okay, and then for evening, I sold another 280 of the oranges. Then my ratio at the end, okay, my ratio for left to my at first is 3:5. Okay, or rather maybe I will change the position. Okay, 3/5. So maybe I put down at first got 5 and you're left with 3 units. Maybe this will be better. So I will put down my total, or at first, like at first sounds better. At first to my left. So this is 5:3. Okay. So again, same idea. You look for your common base. Any common base over here? Yes. Your 6 and 5. 6 is the amount of oranges you have at first. 5 is the oranges you also have at first. So I will multiply this side by 5. I will get 30 is to minus 5 is to 25. For my right hand side, we'll multiply this by 6. So I get 30 is to 18. Okay, that's the common base. So do you see now I can form my equation? If I have 30 units at first, you're left with 25 units after you sold 1/6 in the afternoon. Means 25 units. I minus of 280. I get my 18 units at the end. Correct? 25, this is our before change after, in case you have forgotten. So after you sell your 1/6, I have 25 units. So 25U minus the 280 oranges that you sold in the evening, you get your 18 units at the end. So 25U, you minus your 18 units, you get your 7 units. So this 7 units is my 280 oranges. Okay, so now I can solve for 1 unit. So 1U will be 280 divided by 7. This gives us 40 oranges. And you want to find your oranges that will pack into the boxes. Okay, so if I look at the ratio, if you have 5 units at first, you're left with 3, means that you sold your 2 units of oranges. And if I multiply this accordingly, I'll get my 12 units. So you're looking at 12 units. 12. Oh, sorry. You're not asking for the sold oranges, my mistake. Okay, they are asking for the oranges back into the boxes, the remaining oranges. Okay, so straight away you can find your 18 units. Okay, because you are left with 18 units. So 18 times your 40, I'll get my answer, 720 oranges. So that's the answer for part A. Now for part B, she packed 20 more boxes with 8 oranges, then boxes with 12 oranges. So how many boxes were used to pack your 8 oranges? Okay, so for part B is that your quantity value concept. So you can draw your model. So you have your 8 oranges versus your 12 oranges. Okay, if I put OR for oranges. So the one in the 8 orange box, the box with 8 oranges, you have 20 more boxes. Okay, so this is 20 more compared to the ones with your 12 oranges in one box. Total oranges is 720. Okay, so you have something like this. So if you recall your quantity value concept, first thing is not to minus off 20, is to minus off 20. Okay, but do you divide by 2 in this case? No, this is your grouping concept. So I find this extra 20 boxes. Okay, by the way, do not take 720 minus 20. This 720 is the oranges. This 20 here is the boxes. Maybe I put here quantity for your boxes. Okay, so 20 boxes multiplied by 8 orange in one box. I get 160 oranges. So now I can minus off from my 720. Okay, so once I subtract, I get my 560. So can I take 560 divided by 2? No, because this is your grouping. So I know that my 560 oranges is for equal number of 8 and 12 orange boxes. So we draw your one group. If you recall back, this one group contains 1 times the 8 orange and 1 times of your 12 oranges. So I find first the number of oranges for my one group. Okay, so 8 plus my 12. My one group, that's 20 oranges. I want to find the number of groups. I will divide accordingly. Okay, so number of groups. I will take my 560 divide by 20. So I get my 28. So here there's 28 boxes, and here there's also 28 boxes. So how do you find the number of boxes for the 8 oranges? I need to remember to add back my 20. So 28 plus my 20, you get back your 48 boxes. Okay, so that's the answer for part B. Okay, let's move on to the last question for this paper too. Okay, so question 17. So below shows the prices of some items at the bookshop. Now part A, Kenny bought 2 calculators and 16 notebooks for $60.30. There was a discount given on the calculators only. So what was the percentage discount of the calculators? Okay, let's try to find the cost for 2 calculators. Okay, so the cost for 2 calculators will be 2 times my 2580. Okay, 2 times my 2580. Oops. So 2 times 2580, I get my $51.60. And then 16 notebooks. So every 4 for 540. So I need 4 sets of that. 4 groups of 4 will give me 16. So 4 times my $5.40. I'll get my $21.60. Okay? Now, how do you find the cost of your, hold on. Okay, so if I want to find the total I spent without discount, okay, so total without discount will be my $51.60 plus my $21.60. Correct? So this will be $72 and okay, $73.20. Okay, $73.20. This is for total without discount. But because you spent only $60.30, I will try to find my discount. Okay, so my discount will be $73.20 minus of my $60.30. So my discount will be $12.90. So find your discount first. This discount is solely for your calculators. Okay, so how do you find the percentage discount of the calculators? So discount over your original cost of your calculators. So I take $12.90 over my original cost is your $51.60. Then you multiply by your 100%. So make sure you don't put your $12.90 over your total cost of your items. It's only for your calculators. Okay, so when you plug in the value for your denominator, it must be the value for your calculators. So I should get my 25%. Okay, so that's the percentage discount on my calculators. Now for part B, so this is for part A. So for part B, Mr. Ho bought an equal number of calculators and notebooks without discount. He spent $147 more on the calculators than the notebooks. So how many notebooks did he buy? Okay, so for the next one, if I want to buy equal number, I look for my lowest common multiple of 4 and 1. In this case, my one group must have 4 calculators as well. Okay, so for part B, there's no space because my handwriting is huge. So I will try to find the cost for 4 calculators. 4 times my 2580. So I get my cost, which is 103.20. So my one group, if I were to draw my grouping, I have exactly 4 calculators and 4 notebooks. This is my one group. Because you want equal number. Okay, so let's find the difference in one group because you're given your total difference. So difference in one group will be my 103.20 minus of my $5.40. So the difference in one group will be $97.80. Total difference is 1467. So let's divide to find the number of groups. Okay, so number of groups. I will take my 1467 divide by $97.80. So I will get my 15 groups. So how do you find the number of notebooks? Okay, so one group there's 4 notebooks. I have 15 groups, so 15 times 4, I get my 60 notebooks. So that's the answer for part B. Okay, so we have come to the end for this week's examination paper. So please ask your teachers any last minute questions, any burning questions if you are still not very clear on your concepts or anything you want to clear your doubts with. I wish you all the best for your PSLE. Okay, thank you for watching the video. Goodbye.